Good afternoon, everyone. Such a privilege to have Mukesh with us. Our association has been there for many years, and it's our privilege today to be having him as one of our masterclass speaker. I'm sure there's so much to learn from him. I'll start by introducing myself. I'm Deepti Atul Goswami. I'm the master franchisee for TAB in India. And without further ado, I'd like to welcome our eminent speaker of the day, Mr. Mukesh Goyal. So Mukesh, he brings with him a rich hands-on experience in the manufacturing sector as well in operational leadership. He has previously served as deputy head for plant operations at Hero MotoCorp, where he closely was involved in large-scale operations, process excellence, and technology-driven transformations. At present, Mukesh is founder of Suvagya India, which has been active in working with Indian industries in helping them adopt the Industry 4.0 practices in a practical and result-oriented manner. And that's what he would be talking to us and helping us learn more about how we, as the entrepreneurs of India, can implement these practices and get greater results in a faster way. Over to Mukesh. Take it away, please.
Thank you, Deepti, for introduction. May I request Tejas to present? Okay. So let me welcome all of you for this session on Industry 4.0, as Deepti has already said. So let me thank Deepti, Atul, and TAB team for organizing this. And we have structured in a manner whereby for around 35-40 minutes, we'll have one presentation. And then we can have some 20 minutes question and answer sessions. Is that fine, Deepti?
Sounds perfect.
Okay. So I think it's already covered by Deepti, but let me tell you that I have spent almost, after my engineering from NIT Kurukshetra, spent almost 35 years in industry. And I've been lucky that all the industries or all the companies where I have worked, they were among top three either in world or in India. And I got a lot of opportunity working with a lot of Japanese consultants and got a lot of insight on and knowledge about those Japanese method of excellence, which is like TPM, Deming, and even Lean for that matter. And applying those in the industry, I really I got really tremendous results and in all PQCDMS parameters. Um, After my this 35 years, I co-founded Sugoya India, which is a management consultancy firm, as Deepti was sharing, and we support the manufacturing industry in their next level of growth and even make them globally competitive. So in our portfolio, we also work on business transformation and restructuring, cost efficiency and productivity improvement, creating quality system for zero defects. Industry 4.0, in any case, we are here to discuss. Shop floor ready manager, this is we just started, whereby we realized that a lot of industry or a lot of companies, they're struggling with it. So having a lot of experience of shop floor and how we can make them, ready for the shop floor. So I think that's the one program which we have just started. And we are also assessing business process effectiveness in some of the industries. And definitely we are supporting in industrial engineering like PMTS or time and motion study, and even in the any aspect of factory management. So I would say that you can go to our website of sugoyaindia.com, where if you can get more details. But let's come to the subject, which is Industry 4.0. So what exactly is this Industry 4.0? For some, I think most of you might be knowing it, but for some, it is a new subject. It's a basically evolution of industry worldwide. So it started in, I would say, the 17th century with, or 18th century with Industry 1.0, when industry moved from hand production and animal power to steams and water power. And the early adopters were textile manufacturing, iron manufacturing, agriculture, and mining industry. And that continued till I would say the 19th century. And somewhere in 1870, this industry 2.0 came when the electricity came into picture, and then that became the main driver for industry, further progress. And motors became quite prevalent as compared to earlier steam and water. And even during that time, mass assembly lines, mass production started. And I would say the installation of extensive network of railway and telegraph also started during that time. And coming back to 20th century, when we say that we reached to industry 3.0, which is ideally when when computers got inducted, automation got inducted, IT got inducted, PLC and robo started. So that's what we call it industry 3.0. And in 21st century, in 2011, Germany government, German government first time declared that all the digital initiatives which are going to be in industry, they termed it as a industry 4.0. And it is a digital revolution which started happening then on. And it jump started all those activities on digital front. I'll not go into that detail because in any case, all the subsequent slides, I think we'll be discussing on this. From here, I hand over to my colleague, Tejas uh, Bakliwal, who is our expert in Industry 4.0. Tejas, go ahead. You can unmute yourself.
And good afternoon, everyone. Thank you for having me here. So, every industrial revolution changed who led, and who followed. Industry 4.0 is not different. It's just redefining the manufacturing leadership. So, Industry 4.0 is not about machines, are not about automations. It's all about the data, what data we are getting from the factory shop floors, and based on data, what decisions we are taking based on data. So it's the revolution of decisions, not the revolution of machines. So and Industry 4.0 is not a software that is installed, it's a journey complete. So every successful journey starts with the correct sequencing. So the sequencing of Industry 4.0 is basically digitization, then digitalization, and then digital transformation of your complete factory. So basically transforming all your analog data in the digital first. Then using digital technologies to improve your data, improve your correctness of data, and improve and based on the data you're getting, improving the processes of your current business. That is the digitalization. That is actually using the digital data coming from the shop floor, and then leveraging all the different technologies based on the data you have, and leveraging the technologies, merging the technologies and data, and then taking the actions based on data. That is the digital transformation of the complete factory. So 70% of digital failures comes just because not understanding that the journey is right from foundation, then improvement, then revolution. Everyone thinks of like, okay, I'm getting the data, and then he thinks of, okay, I must get a revolution in the factory. So today's manufacturing journey is basically manufacturing today is really under pressure from all the directions. Costs are rising, customers are demanding, margins are shrinking, supply chain is too volatile. So, addressing all these things uh, in a single domain is basically Industry 4.0. So, margins don't get disappear suddenly, they leak daily. So, controlling on all these things like wages are increasing from uh, in last 4 years, the daily wages have been raised by 60%, or the inventory carrying cost in India is around 15 to 20%. So controlling all these things ultimately lay us to implement Industry 4.0 practices. So what is the solution for this? So solution for this is not about automation. It's about getting the things done intelligently, creating the values out of what we are manufacturing or how we are manufacturing. So our machine, data, and people, if we amalgamate all these things and we connect all these things, then our factory becomes more agile, more efficient, and more intelligent. So this will give us the data-driven decision making, and data-driven decision decides the 3x faster or 4x faster things based on the data we are having or data that is available. So coming on to the digital transformation. So digital transformation is often misunderstood like it is a technology or it is a technological adaptation. In reality, it is all about how the decisions are being made. So based on the data and based on the technologies that are available, we can just combine both data and technologies, and we can improve our digital transformation journey or improve our decision makings. Like we can adapt various technologies to take the data, various communication mechanism we can establish, data driven decisions we can take. Then IoT is there, data driven systems can talk to each other and then take the decisions. Then various automations are levels are there wherein based on data, based on the things coming on to the palette, automations can be done, AI can be increased, and networking can be increased. So this is the journey of digital transformation. So 80% AI projects fails due to the unavailability of data. So the digital transformation journey starts with accumulating the data and then putting it in the AI for the further analytics or further usage of digital transformation. So Industry 4.0 lies on multiple pillars. So there are 9 different pillars for Industry 4.0, wherein the combined solution or combined working of the system brings us on the platform of Industry 4.0, which includes autonomous robots or the autonomous systems, simulation, then system integration, IoT, cybersecurity, cloud computing, additive manufacturing, augmented reality, and big data. So the foundation is basically the complete universal connectivity of all the devices based on these 9 pillars. Then the brain is basically data-driven intelligence, like all the things that my factory will be working on or my factory's decision will be done on based on the data I have. And the action will be all physical and human machines and physical machines. All my operator, all my machines, all my tools, all my methods will be aligned to the data that I have or the foundation that I have. So this is what the 9 pillars of Industry 4.0 suggest. So it is basically a digital nervous system, like all your sensors, like a body, all your sensors in the factory are nerves, and all the analytics that based on that sensors will be done in the brain. So basically, Industry 4.0 is a brain behind taking the decision and then connecting the factories. So 3 things that are very much important in this data is, one is system integration. So my system must be integrated to the sensors, to the field devices that gives me the data, or that can enable me to take the decision based on data, which we call a smart decision or decision that a computer program or decision that a complete AI system will take. Then we have an industrial IoT system wherein my all devices are capable of switching on, switching off, or taking any of the devices, any of the decision based on the data availability, like predictive maintenance, if we say. So if my bearing is been filled, or if there is a temperature or there is a exertion between bearing and the motor shaft, so based on the data I'm getting, vibration data and temperature data, my motor will automatically get the information, okay, there might be some failure coming. So my system will give the alerts to my maintenance department, okay, there is an issue over there, and you have to do a maintenance, predefined maintenance on this part, and this is the time the motor is going to be failed. So that is the IoT system that have, or the maintenance person can switch off the motor right from his office only, or the decisions can be automatically taken based on the predefined rules I have. Then coming on to the cloud computing, all this data in today's age is a age of system, age of softwares, age of AI, and I can process my heavy duty softwares or big data in a system that is available at my factory shop floor, or system that legacy systems I have. So I'll require a cloud computing thing over there. So cloud computing is basically computing all the data in a central server, wherein all the data is computed based on the data I have previous, all the data I have available, and then taking the decision based on that. Now coming on to the reactive to predictive intelligence. So based on, as I already said, that based on my previous data or data I have, and based on the simulation data I have, I can take all the my reactive maintenance to a predictive maintenance. Like most of the factory react after the loss occurs. So industry 4.0 enables you to predict the loss, and before loss happens, take the actions on it. So predictive factories have very less breakdowns or less MTTR in the factories. Now the agile factory, as nine pillars says, two pillars are autonomous robots and additive manufacturing. So agility is a new efficiency model that factories are adopting. Like cobots, they are adopting. Cobots can work with humans. Cobots can take their own decision based on the product that are coming. So agile, every new product, or what we say is the batch size of one, is very much possible due to cobots. We don't have to train them, we just have to give them data. Based on that data, cobots can take their own decisions and do the things. And second agility mechanism is additive manufacturing. Like if I have to do something in R&D, or some product which I have to make once for the trials or testing, so we can do 3D printing and other things. So that technologies are available to make the factories more agile and give the new efficiencies to the factory. So technology should amplify people, not replace people. So these two uh, technologies, like augmented reality and cyber security, amplifies people with the more of a detailing in a complex practices. Like augmented reality helps the person to analyze the complete shop floor sitting in his office, and then analyze what can happen in physical world just before placing the things physically. So that is the goodness of augmented reality. And cyber security is basically all my data or all my softwares that are in the factory, that must be safe, that must be flexible, so that no third party attacks or no viruses can attack my factory. So this is the context of industry 4.0, and these are the nine pillars of industry 4.0. So what a smart factory does, or what industry 4.0 means, is adopting all these nine pillars in the way as and when required by a factory, and connecting all these nine pillars enables you to justify yourself as a smart factory, or justify yourself as a intelligent factory. So, Operetex is our digital platform uh, which supports Industry 4.0. So, let's look it as a real manufacturing environment, or high mix or legacy machines if you have. So, Operetex is a digital manufacturing platform that can be implemented, or that can be adopted by a manufacturers, which has brownfield manufacturing, new facilities coming on, or any of the product environment or any of the production environment, you can adopt Operetex as a platform to enable you to adopt Industry 4.2. So, what business challenges we have? One is fragmented shop floors we have, like across various PLCs, we have various tool testers are there. All data is been logged manually. Second business challenge what manufacturers have is there is no end-to-end traceability of any component, any process, or any test result. Third challenge what manufacturer have is the manual quality inspection data is there. So anything now the quality is not a USP of any company. Quality is a mandatory part for any company. So quality is not what you can sell to the customer. Quality is now a mandatory thing. Every customer must have a quality product. So what bottleneck the quality have is the quality inspection we have is manual quality inspection we have. And for a efficient factory we have a high unplanned downtime. And as I already said, Industry 4.0 enables you for a predictive maintenance. Now what we do is a reactive maintenance. There is no correlation between production, energy, performance matrix, machine matrix, skill matrix of the operators. So all these things we have to establish a correlation between all these things, and this is a big business challenge nowadays, that there is no correlation between all of these points, which ultimately leads us to our decreased efficiency and decreased margins. So here we are leaking the margins up. Now, management decisions are driven based on the Excel reports we have. Uh, we don't have the management decisions are mostly based on the Excel reports, not based on what actually is happening on a shop floor, or not on the real time data that a shop floor has. So, all these things, all this business challenge requires a scalable Industry 4.0 solution. So, Operetex is a scalable Industry 4.0 solution, which addresses your many of the challenges. Like very first challenge is unified data integration. So, currently what happens in a factory is you have multiple data sources, scattered data sources. Like there are n number of PLCs, n number of CNCs, n number of DC tools, n number of testers, n number of vision systems, and these all things are not connected or not natively integrated. So Operetex is a unified data platform wherein all your shop floor equipments can be connected on a single platform, which enables you to take the data on a single platform and then apply the rules on that data based on the experience or based on the industry practices. And then based on that data, you can analyze the data, or then based on that data you can take the decisions. So benefits of unified data integration is you get a single source of truth of your shop floor factory. You get faster deployments in the your brownfield projects. You get vendor agnostic and future ready architecture you have. So if you are getting all the data, then you can plan for AI, you can plan for auto decision making, you can plan for IoT. And this is unified data integration is a architecture or foundation for your MES, analytics, AI, and traceability things. Second pillar of Operetex is plant performance monitoring. So this are specifically for automotive and assembly, EV assembly lines, home appliances, consumer durables, or FMCG type of industries. So the major challenges for the industries, there is no real-time data, or there is no visibility of what my operational efficiency is. Second is all downtimes are logged manually after the end of shift time of factory. So yesterday's downtime will be downtime history will be logged today or after the shift based on the supervisor or the manager's availability. And based on that data, which is entered after the incident happened or after 1 or 2 days, that is put in Excel, and based on that Excel, the complete decisions has been made. So the basic thing about this is you have ultimately your data is wrong because data is not real time, and when your foundation is wrong, so all decisions making on based on that foundation will ultimately go wrong. So what solution we have implemented is real-time OE calculations, like real-time availability, real-time performance, real-time quality inspection. Then capturing the downtime reasons from the PLCs, operators' inputs, and other things. Then shift-wise, line-wise, and product-wise, mapping all the data on that uh, based on what product has been manufactured, which shift, what was the environmental conditions, what was the line, what was the operator, and everything. So when we correlate all this data like man, machine, method, tools, material, all this data, all 4MT conditions are being correlated. So based on that, the companies get a significant improvement of 5 to 12% improvement in OE. Faster root cause analytics has been done, and then data driven decisions are made daily, and the improvement in productivity and line stability ultimately comes. Then coming on to the utility cockpit. So every company has their own utilities in the factory, but that utility nowadays is scattered. My air, my energy, my compressed air, my energy, my fuel, all things are available, but available in very discrete manner. And all the data taken from for the utility are basically a time-based data. So we are not getting any real-time data or real-time information of your complete utility. So utility is very a big fixed cost for a company, but the bad thing about that is we don't have real time data, or we don't have any real time things. So what it is not a fixed overhead nowadays. It must be correlated with your product, it must be correlated with your number of product manufactured, it must be correlated with your selling point of a product or selling cost of the product. So nowadays it is not correlated. So when we manufacture the plant uh, product, so we must have the visibility of our complete energy consumption, complete fuel consumption, complete air consumption. And based on that data, we get what energy per part I am consuming, what are the peak alerts, what is my maintenance alerts, what was my fuel consumption per part, what was my light consumption per part. So that real-time visibility a company must have. So after having that real-time visibility, companies have seen huge benefits in the energy, and energy is ultimately contributing to the EBITDA of a company. Now coming on to the production and traceability. So traceability today is not about the compliance of a customer. It's about the speed and risk reduction of a company. So what traceability can be implemented in various types of industries like automotive, it's a EV or aerospace or defense. So what challenge currently the company has is there is no end-to-end traceability of a part or process, or there is manual process confirmation and data gaps. And due to this, there is high risk of quality or recalls or audit. So what solution we have implemented in this is see, logging all the data of quality, all the genealogy of the quality, right from material to process to test to dispatch against a serial number of a part, and then tracking all the quality data based on the process capability and based on the machine capabilities. So what benefit the company gets on this is there is 100% digital traceability, faster root cause analysis, then reduce recalls and complaints, and audit ready digital records. So after implementing this production and traceability module, companies got a recall cost reduction of around 60 to 80%. Cost has been reduced on recall of the products. Now, human inspection has a limited capability, or human inspection is limited by fatigues. So vision brings consistency, vision system brings the improvement in quality. So manual inspections are operator dependent, and the chances of error are huge in this. And there is no evidence of what the quality person has tested or what that human has seen. So vision based systems enables us to take the image, apply our own AI based rules for the camera. Then based on that, we can label the product for verification, and automatically OK and NG decision is been taken. So what benefit we get is 100% inspection with zero human bias. There is a zero defect escape to dispatch, faster inspection cycle, and all the quality results are stored for the future analytics or future evidence for the customer. Now, part genealogy. So every critical component has its own story. Industry 4.0 ensures you that that story is never lost. So taking on to a critical products like cylinder block or cylinder head or any of the 5C components of a industry or automotive industry. So we need a end-to-end traceability or end-to-end part visibility of a particular part. Like what happened in machining, what happened with raw material, what happened in inspection, what happened in sub-assembly, what happened in assembly, everything. So complete genealogy is very much important for a particular part when it comes to a traceability. So all data of that part is been again logged against that part's DMC or part's barcode, and based on this data, the data is been analyzed from time to time, and decisions for machining or decisions for improving the efficiency of that part are been done. And 100% part level traceability is available, faster root cause analysis is available, reduce cost or reduce rework cost, scrap cost, or warranty cost is benefited. And the main thing is we are audit ready for any OEM complaint. So we have digital records of all these things, and we are ready at any of the real time for audit. Now coming on to the add-ons. So add-ons are basically the real-time visibility of your complete plant in a shop floor. Now what happens is uh, are all the responsible person in a shop floor factory like supervisors, manager, their responsibility defines the excellence of a factory. And if the speed of their responsibility increases, or if the data or speed of their response increases, their excellence increases. So add-ons and alerts gives you a real-time data of your factory. Now, what happens in legacy factories are the shop floor data or the shop floor emergency or shop floor alerts don't pop up on very real-time basis. So if my I'm not getting the data on real-time basis or calls on real-time basis, my response speed of response will be very less, and speed of response defines my excellence of a factory. So delays silently consumes your productivity. So smart add-ons enables you to trigger your quality failures, trigger your machine failures, energy abnormalities, and this enables you to get your real-time factories information and then circulate it to your supervisors or your managers on the shop floor. So, what benefits or what leadership invest is in on results, not on technology. So let's look at a measurable impact of what Industry 4.0 or what this 5 6 models what I have explained you has impacted in results. So productivity has been improved by 8 to 12%. There is 100% traceability and process inspection in terms of quality. In terms of cost, there is in reduction of 8 to 15% in energy cost and scrap and other rework. Delivery is predictable, your output is predictable, like what you are going to manufacture, what is the real time status, everything is real time available. Safety is increased as the manual inspection or manual fatigue is reduced, and the morale is increased of the management because you get real time data rather than having a Excel based manual data. Now, let's move at what global leaders have done while implementing Industry 4.0 at their factories. So, what global case studies are available on Industry 4.0? Like, what was the challenge? What was the solution implemented by global leaders, and what benefits they got? So, BMW implemented digital twins for their complex factory planning. So before planning the factories, they implemented a complete factory on a digital twin on a soft platform. And after complete simulation of factory on a digital twin, they got faster. They were able to make the planning of a factory very faster. They were able to adopt agility, and the efficiency and time to getting the productionized of factory reduced by almost 50% for them. Now, Volkswagen Group has implemented a complete factory cloud, like digital platform for complete production platform for across their 43 sites. So, all the productions, logistic data, multi-plant network, efficiency, cost, all the data is available on real-time basis on a cloud, and that cloud is then on a cloud-based platform. They are taking analyzing the data on real time basis, and based on that real time data, they have been able to save tens of millions of euros based on that data itself. Pfizer has implemented predictive maintenance in very long way using the OT data analytics, wherein they have got a centralized OT data collection of a complete all the equipments of their factory, and based on that they have reported a huge reduction in downtime, and their productivity has also been increased. GSK, which is again a pharma manufacturer, has implemented smart manufacturing in digital twins for their early failure of detection of components. So they have taken real time data of all the factory shop floor equipments. They have given the advanced analytics and digital twin like approach to detect early signs of the faults, and based on that they have unlocked the complete capacity of a factory. So they have now more batch productions per year, earlier intervention to a poor quality and speed they get. So this is the benefit they've got. So Electrolux is a home appliance manufacturer. So they have standardized the complete industrial network of their factory and automated the OE calculation of their factory. So based on the real-time data they are getting, they have automated the OE calculation. They have reduced the scrap and defect rates. They have increased the supply chain resilience, and the downtime has been decreased and productivity has been increased by them. Now, Whirlpool, so new plants today are born digital. So Whirlpool reflects this. Whirlpool has introduced a digital factory in their dishwasher plant, and they have got a complete MES and traceability model in that. So a new plant is benchmarked with the complete digitalized facility. All the data has been logged in MES and SCADAs, which enables their management to take the decisions based on that. And they have complete traceability of the factory. So what benefits they have got is complete plant has described huge productivity. 80% things are automated and enabled for traceability, and decision makings are happening based on the data itself. Then Siemens Electric is a lighthouse for a smart factory. So sustainability and profitability comes together. So what challenges Schneider Electric had was their productivity improvement while reducing the energy efficiency was the challenge to them. So they introduced the complete stack of Industry 4.0 with central control, real-time dashboards, and automated AGVs. So based on this, since 2018, they have reported 25% reduction in energy and 17% reduction in material wastage they have. Unilever. So Unilever is World Economic Forum's lighthouse project they have done in digital twin, and this factory is located in Sonipat itself in India. So they have implemented a digital twin and AI for their complete energy models and their physical systems, and based on that they have reduced 96% cut in their emissions and reduction of energy uh, after implementing digital twin in their factory. So Inal Green Power has also implemented the complete plant performance system, wherein they get the complete KPIs of the plant on a central dashboard, and based on that, the decisions are being made using AI things. So the connectivity is the tissue of a complete factory. A smart factory cannot work alone. The integration matters. So complete integration comes with the horizontal and vertical integration both. All your supply chain, logistics, factory, shipping, customer must be integrated. Apart of that, all data of all this, uh, all value chains must be integrated to your cloud platform. So based on the vertical and horizontal integration, the decisions takings are more efficient and more result oriented. So coming on to the reality rather than theory. So India today is at an inflection point wherein India can lead, not follow. So all we are being looked as a second to China. So our product must be efficient, our product must be quality oriented, and the cost of product must be less. So we need efficiency across our complete manufacturing chain. So Industry 4.0 is a value-added tool that manufacturers can implement and increase the efficiency of a complete factory. So transformation without roadmap fails. So this is the phased roadmap for implementation of Industry 4.0. It is not been implemented overnight. You have to strategize you and assess your assets. Then you have to implement it in a planned pilot way. Once the pilot is successful, then you can scale it to various devices or various factories of yours, and then based on the data you have, you can optimize and innovate new things based on the data you have. So this is what the future of Indian industry is. It starts now with Industry 4.0. Over to you, Mukesh sir.
You can stop presenting, Tejas.
Yeah.
So thanks, Tejas. So any questions from your side?
Yeah, good afternoon, Mukesh ji.
Good afternoon.
Yeah, this is Balaji Jami. I'm basically a budding entrepreneur at the age of 46. Basically, I've been working with industries like Renault, Nissan, TVS Motors, and all these things from 2004 to 2015. From 2015, I started my own business and started doing it. I have two fundamental doubts here. Sorry to, it's like maybe it's a silly thing what I'm asking. Because what is the poster you have shared is about Industry 4.0. Is it about something like a software or a solution you are trying to give, or are you trying to explain the current situation of an industry? This is the first question. Second question, what Mr. Tejas has presented out, uh, maybe I am a 6 Sigma black belt and a TPM certified guy. These are all been doing it in 2010. We have been implementing different ways because I'm a freelance. I worked as a freelance consultant for more than 3 years. Uh, then what's new thing in Industry 4.0 you're trying to incorporate, because you are talking about predictive maintenance, preventive maintenance, and reactive maintenance, where you try to integrate data and all. This is all comes under TPM, which people have started implementing in 2008, 2007, and started getting results. So what's new in this first thing? And what are you trying to, what is your target industry uh, by presenting this? These are the two questions I've asked. Sorry, my questions might be very silly, but sitting for 1 hour here, I didn't feel like something. I was industry 4.0. I was thinking something new I'll be learning because I'm basically from industrial background with 10 plus years of experience as a quality
So,
operational and purchase in.
Balaji, can I answer?
Yeah,
Okay. So, thanks for your question. First of all, I myself have worked in all those methodology of TPM, Lean, Deming, right? Uh, in any case, what we are talking through all those processes, even TPM for that matter, you have to collect the data and measure the losses, and you keep working on losses, reduction of losses. I think the industry 4.0 is facilitating that process by digitizing all your losses and data, which many times is being done manually, and many times the authenticity of the data itself is a question mark, right? And I myself have experienced that people coming out with the data whereby they're showing some losses, but when you do the reverse calculation, vis-a-vis what it should be, the production for the particular day, and then you realize there's a big gap whereby a lot of data is not getting noted in that itself. Just a facilitation of your existing system by making it digitization and also converting into auto collection of the data, auto analysis, and definitely auto, I would say, that helps in taking a lot of decisions proactively. And that's also online. Again, many times in past, we used to collect the data at the end of the shift or maybe end of the day. Here we are talking a lot of data will get collected online, right? So that's what is the industry 4.0 is, right? And then there are multiple tools in that, where like digital twin, it has got a different application which has been expressed by pages. There are other lot of analytics which have now started going automatically. A lot of dashboard which you can get, right? Even a lot of remotely you can control a lot of equipment. So those are the things which are getting facilitated in industry 4.0. Secondly, let me tell you, we are not selling any product here. It is just for the information of the team here. I think I have been requested by TAB team that there are industries which would like to know and understand about Industry 4.0. And I think they told us that though it is already prevalent for almost 10 years now in industry, but still they said that many of them will be getting exposed for the first time. So a lot of those primary and basic things have been covered. Hope I answered your questions.
yeah, but the point again here is your target audience is not. Uh, Sorry to say this because you should have like the pitch what I got, the poster what I got uh, says something different than what is explained here. That's what the point I raised. Nothing more than that. Sorry if I'm wrong on this. It's like if you have a specific target audience like whom you want to address, this would be a better session for people
We
who.
will leave it back to TAP. I think they have
Mm,
called for this. So
yeah,
thank you for your question. I think let's move to the second question.
yeah. Thank you.
Okay. uh, in Tejas's slides, he mentioned about this Operate X. Is that an implementation methodology or what is it? What is Operate X really?
Opetex is a platform which is a provides all those services of Industry 4.0, and this is part of our one partner company which has actually developed this and supporting the industry by implementing this.
And this platform, the developer company is an Indian company or it's a international company?
It's an Indian company.
It's an Indian company. Also, what I noticed is that OperateX has several modules. So, is
Yes.
it possible for an modular implementation? Somebody could start with one module and then grow.
Yes, definitely. Based on based on your requirement, it can be accordingly provided. Only that one module can be provided. That's what I think. What Tejas was also referring that any implementation of Industry 4.0 is not one project. It is multiple projects, right? So you start with one project whereby it is ROI based project which is implemented, and based on that, based on the needs, and then maybe a lot of analysis which we do on the shop floor, what exactly is required for that particular industry. A lot of other projects can be taken up over a period of time.
So, as an example, if somebody wants to start only with the energy uh,
Yes,
piece
yes,
of, that's possible.
possible, definitely possible.
Okay. The other question that I have is Tejas spoke about a lot of industries which are mostly international giants, the BMWs and Volkswagens, and the only Indian one that he mentioned was Unilever and Sonipat. Are there more Indian case studies that we have?
Yes, even I tell you, I worked in Hero MotoCorp, and we have implemented a lot of projects. And those lot of projects are appearing here, maybe in terms of under that, Operatex platform. But then, by and large, those projects are same, which are implemented. Even I think Bajaj has implemented a lot of them. TVS has implemented a lot of them. Tata has implemented a lot of them.
Okay. And my final question is do we also have some SME case studies, some early adopters in the SME segment?
Tejas, can you throw some light on that?
Yeah, we have some SMEs case studies also, like small machine shop owners, or the companies with 10, 20 machines or 30 machines has also implemented this.
Okay.
Even a
Yeah.
single, you can also you can
Yeah.
start with making your single machine a smart machine, right? Not necessarily that you have to make complete machine shop or complete whole of your line smart. So you can even start with single machine,
Sure.
whichever is your bottleneck machine. You can start with that and then can expand over a period of time.
Sure. Thank you. Thank you, Mukesh. Thank you, Tejas.
Please go ahead, Mr. Rahul. I think you have raised
Yes,
your hand.
good afternoon. My name is Rahul, and we run a company, a 50-year-old company, 50 plus years in heat treatment in Bangalore.
Thank you.
And we have been over the years, so to say, increasing the automation in our plant. We've always had an ERP for more than 25 years now, and it's undergoing its latest change to, bring in more, let us say, paperless work, basically. And second thing, we also have SCADA. We are continuously increasing digitization from simple on-off controllers. We went into PLC-based controllers for our furnaces. And along came Industry 4.0 as a buzzword. We've been hearing about it for probably at least 3, 4, 5 years now. So what I want to ask is like for other systems, say, talk about NatCap, ISO 9000, 14,000, you have qualifying criteria to say that, yes, you're compliant with these standards. What is it? When can you call your company or your working system as Industry 4.0 compliant? Right? When do I know that, yes, we do compliant? Or in other words, what is the qualifying yardstick to say that you are Industry 4.0?
I would say, first of all, that assessment can be done by us as well, right? Whereby we try to see you that where you stand vis-a-vis those implementation. But ideally, I think everybody is looking for addressing their pain areas through this, right? Rather than where they stand on, because it's not a something which is legally which is required, right?
Yeah.
Or but then I think there's a international mechanism which is known as Siri, which actually shows you where you stand.
Mm-hmm.
And so there are some Siri assessors which are available in India, which actually gives you your standing vis-a-vis world. And in some developed countries, my understanding that they have made it mandatory for getting even your loans. So you get your loan for digitization, loan for maybe expansion to some time, depending on where you stand, because it is also linked with the sustainability measures. Because a lot of electricity or energy saving, which results into you standing better as compared to other industries. So in some countries it is started, but not in India.
You had a question?
Digital twin.
Yeah, but we also heard about the digital twin now. So is digital twin something like a simulation of the factory to be in advance so that you can understand how work and data movement happens and kind of identify if there are any issues, troubleshooting before actually going in for setting up the factory? Is it something like that?
You have already answered it.
No, this is what I got from
But
what
yes,
Mr.
yes, yes,
Tejas
yes.
said.
So
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 I'm just
is so
confirming, is this what
digital
it is?
twin is meant for this, that
Yeah,
you create before you go physical.
yeah.
You actually create a digital model and
Okay.
test every conditions which you want to put it, including your manpower deployment, even I think the station size and even your machine and other conditions. So you try to test simulate in that conditions, in virtual conditions, so that as you put it physically, all those
Yeah,
things. So your ramp up and then speed of ramping up becomes quite high.
agreed. I just see one challenge over there, that the challenges and the variables which we encounter in real time in running a machine or a furnace, especially a furnace, what leakage will be there, what will give up, compared to a digital simulation, whether a digital twin will be able to represent all those variables is a question. And secondly, I guess I'm very sure that we don't have within the organization the capabilities or competence to create a digital twin. And then if we engage with somebody like you, who is an expert in, say, Industry 4.0, but not an expert in my business, then the amount of time taken to kind of make you understand the realities on my shop floor, we find are very challenging. We found that even in getting an ERP made, I mean, tailor-made, none of the standard ERPs available in the market either. We are a SME basically, and all the standard packages for ERP coming out in the market, there are umpteen, literally, I can say thousands of people selling ERP. But we knew that when we engaged with them, for them to comprehend, probably put down in black and white what we want exactly, we found as a big challenge. So we finally were comfortable with the person who first made our ERP. He made the second version, converting it from DOS to Windows about 15 years back. And now he's the same person again who is increasing, making it IoT, compatible and things like that, and even linking our ERP to our SCADA. He is able to comprehend. So this is a challenge we find when getting it done externally. Internally, we don't have the competence to digitize and imagine how a digital twin is made. So I don't know what your comments on this are.
Tejas, would you like to answer?
So, digital twin for a majority of equipments, like you say about furnace. So there are standard modules developed by the companies like Siemens and other things, like what all parameters of the furnace must have. Once you input all that parameters with your furnace size and everything, it will give you a digital version of your furnace first. And then you can simulate like, okay, what if I overload a material in that? Or what if my temperature is increased from 1500 degrees Celsius to 1700 degrees Celsius? What will happen? What will be my energy consumption? What if my material drags? Or what if my liners of the furnace, what will be the life of my liners? So on the all of these standard parameters, you can configure that digital twin. So it is more of a configuration based on what international standards are available for a furnace or for particular equipment.
Okay, so they have kind of designed a standard model, and for which you got to give your parameters. Okay, got it. It will, of course, based on some kind of a standard design of a furnace, represent the furnace digitally. I guess that is what they'll do.
But they
Right,
just wouldn't
exactly.
this specific case have to be trained with data from the actual furnace?
See, there are two types of digital twin. One, we are simulating on a ideal conditions. Second, we are simulating based on the data availability of shop floor I have. So if I have a background data, like if I say a steel plant and a steel plant's furnace. So if I have a background data of last 1 year, 2 years of my furnace, I can simulate that data also on my new furnace.
Wouldn't that be better?
Yeah, that will be better, but the prerequisite for that is I must have data that all functionalities are available in digital twin module.
We
Yeah.
have to first we have to have
One
a
last
data.
question, sir, to Mr. Tejas. It's a repeat of my first question. If I have to ask you to spell out the attributes of Industry 4.0 manufacturing system or of Industry 4.0 compliant facility, what are those attributes would you say?
So, see, there are two things, two answers for this question. If you want a certificate of compliance, then for paper like Siri and other companies are there. If you want yourself to analyze, it is a simple answer is if your data is being taken on your decision is being taken on the data, and second, your machines are capable of taking the decision on their own autonomous mode based on the data they have. If these both things are available in your factory, and a factory's owner or management can take the decision on based on that data, strategic decision based on real time data or the true data, you are industry 4.0 compliant.
Should it be the owner or should it be the machine itself which should be taking the decision? So
See, there
based on the load
no,
in the furnace,
there are two things, sir. I'll take a example of a motor. So, if there is a motor, the shaft is getting heated, the bearing is not okay. There is certain rule already given to motor. Motor will automatically trip down or motor will automatically switch off. That is the decision taken by motor. What decision management has to take is this is the make of bearing, this is the make of motor, the both tunability is not okay, either I have to change the make of bearing or change the make of motor. So that decision based on all the data availability, that decision management will take to make my system more efficient.
uh, uh, sorry, my understanding, Tejas, was that Industry 4.0 would mean that when the motor itself prevents itself from heating. See, like you said earlier, that there is reactive maintenance.
That
So
is AI.
reactive maintenance is that your motor is getting heated, right? And
And motor is
you
damaged.
switch it off,
No,
right?
reactive maintenance is
Preventive would be when the system itself is able to figure out that look, the motor is getting heated because of this, and hence it kind of adjusts it, right? So I mean, talking of the maintenance example is that look, there is a breakdown in the machine, and then you repair the machine.
yeah.
And
So
predictive maintenance is when you are actually monitoring the health of the machine and say, are you saying, ki, look, in another 5 hours or another 50 hours, it's going to break down. So stop the machine, repair this part, and then put it back on.
exactly.
So
So there
same
are
thing is with the furnace, right?
I'll just answer.
I mean, we can have it both ways.
There are two ways for this. One is your reactive maintenance. What is your reactive maintenance? My motor is failed. It is not switched off. It is not tripped. It is failed. I have to replace a motor or I have to replace a drive or anything due to my issue of heating and other things. That is one thing. Your reactive maintenance is a cost for you. Your predictive maintenance is you will get 5 hours, 6 hours, or 5, 6 days before the information. Okay, this is being heating up. You have to check and look at this. So these are the two aspects. Now, what management has to take the decision is okay, my maintenance person came, my maintenance person sorted out the issue, and now issue is okay. If issue is coming continuously, it's the management decision to either change the motor or change the bearing make or whatever is to be done over there to not to pile up this issue.
See, actually, let me tell you, the predictive maintenance helps you in preventing the unplanned breakdowns. So actually, you get those senses in advance rather than like as Tejas is explaining that your motor is burnt out or your bearing has gone to such a condition. That's the reason you put sometimes vibration sensor, you put the temperature sensors, which give and you put some limit within your own system that if it goes beyond this, it'll give you an indication. At that time, there's no breakdown and there's no all of a sudden stoppage of the machine. But you can take under planned maintenance based on the data. Because in any case, nobody can actually replace your maintenance work automatically, right? It has to be done manually. But then I think the prediction is that you will get the data in advance. Go ahead, Mansi.
Hi, thank you for giving your time, and the session was really insightful and wonderful. Thank you all the participants, as we are already closing on the timeline of 4 p.m. Requesting all to fill in the feedback form which we have shared in the chat box, and we'll get back to you next month with a wonderful session again on a topic that could be recommended by you as well. I've already added an option in the feedback form. Thank you, Mukesh sir. Thank you, Tejas. Thank you all for joining.
Thank you.
Thank you,
Bye-bye.
sir.